Hi, students. Let's look at the second question I was talking about. A quantity of heat, 550 joules, is required to heat brass at 12 degrees Celsius to a temperature T. Take note of this question. This time we are heating the body. So it's from a lower temperature to higher temperature. The previous question was cooling from higher to low. So take note of that. If the mass of brass is 220 grams and specific heat capacity is 830 joule per kilogram per Kelvin, calculate the temperature T. Wow, this is a very simple question. How do we look at this question? You write down, put down your information. So what does each parameter stand for? We are given this 550 is the quantity of heat, right? So quantity or amount of heat, and is given by Q is 550 joules. So initial temperature is 12. The final temperature is T. All right. So you see that this one we are heating it. So the final temperature will be higher than the initial. But the previous question, it was cooling. So the final temperature was lower. But when we said that whenever you are calculating, it's always the higher, the bigger minus the lower. So if you analyze the question carefully, you could see that this question, the final temperature should be greater. Okay? Because you are heating it. So it will be 12 to T. T will be greater than 12. But the other one, it was cooling. So let's find our change. Our change in temperature, which is our theta, is going to be T minus 12. Take note of that. Let's continue. We are given mass of brass as 220. Grams. And according to you do the analysis carefully, this one must be in kilograms. All right. So we know that 1000 grams gives a kilogram. So 220 grams will give us what? 220 on 1000. 1000, you get 0.22 kilograms. So you divide by 1000. All right. So your mass, this is the one you use. You don't use the 220. Take note of that. And we have been given the specific heat capacity. So when you are doing calculations with this, you ensure that the unit of the mass is in kilogram. You have to check the specific capacity is given in per kilogram, okay? But the difference is that when you are given this one in per Kelvin and the temperature change is in degrees Celsius, for the temperature change, you don't do the conversion. But for the mass, you must convert it when the specific capacity is given in per Kelvin. Per kilogram, sorry. Please, if you have any question, you ask me in the comment, okay? Right. Specific heat capacity. Our small c is giving us 830 joule per kilogram per Kelvin. So what is our focus here? Our information will be deduced from the specific heat capacity. That is where our solution will come from. So I will write. I have used the symbols already. So instead of wasting time to write, let me just use the symbols. It's Q over M times what? Theta, okay? The question wants us to find T. And T is from this equation. Take note. So let's try and make theta the subject. It depends on how everyone will solve it. But this is the approach I prefer we use. Okay. When we make theta the subject, what do we get here? You get Q equals MC theta, right? So then our theta will give us what? Q over MC. So what is our Q? 550. Our M is what? 0.22 times our C, which is 830. So we get 550. What do you get on the calculator? I am getting 182.6. You can confirm from yours. And what do we get here? When we divide, we are going to get, I am getting 3 points. You can confirm as well. 1205 to 5 decimal places. This is theta. All right. But this is not our focus. The question demands we find t, and we have gotten theta as what? T minus what? 12 equals what? 3.01205. 05. Because check. My 5 is not nice to me. Let me write it all. So 5. Come. Yeah, we said theta is this. So I will put the t minus 12 in place of this. And when I add negative 12 on both sides, I will get 1, 2, and this will give me 15.01205. We can't write all because this is our final answer. Let's leave it to, let's see, 2.3. Okay, let's leave it to, I think 2 decimal is okay. Or 3, let's say 3 degrees Celsius. Degrees Celsius because it will take the unit of the initial temperature. The initial temperature was degrees Celsius, the unit. Right. So students, this is what I'm getting for the second question. This is how the question started. We went through these steps and finally ended here. Take your time, go through and confirm the answers and the solution. If you have any question or contribution, share it with us in the comment. See you again.